Chapter 1 Fundamentals of Thermodynamics. Section 1.2 The Zeroth Law of Thermodynamics. It states that if two systems are both in thermal equilibrium with a third system, then these two systems are also in thermal equilibrium. For example, in this diagram, if A and B are in thermal equilibrium and B and C are also in thermal equilibrium, we can conclude that A and C are in thermal equilibrium. Let's define thermal equilibrium. A and B are in thermal equilibrium only if first A and B have the same temperature, and two, A and B are in thermal contact. That means A and B can exchange energy freely via the form of heat. Heat can flow between A and B. The Zeroth law of thermodynamics may be extended as follows. If two systems are both in thermodynamic equilibrium, then with a third system, then these two systems are also in thermodynamic equilibrium. What's the difference between a thermal equilibrium and thermodynamic equilibrium? So in a thermodynamic equilibrium, the two systems must have the same temperature, pressure, and compositions. These two systems can exchange both matter and energy freely. In the end, if two systems can freely exchange matter and energy, they will eventually reach thermodynamic equilibrium. And this is dictated by the second law of thermodynamics.